Alright guys, so we had our station set up in class today for the visible light spectrum, and I wanted to make sure that you guys got the same experience that we did in class. So station 1 was talking about the prism video and just kind of manipulating a prism. And I know that a lot of you probably don't have a prism at home, because I definitely don't. But this is what a prism is. It's just a glass triangle prism, and all it does is it's going to refract light in different directions. So after you watch that video, you'll kind of see some different things that the prism can do. And if you shine it in different areas, you see some rainbows showing up, like on the right hand side of that prism right there. It's very faint, but you do see it coming up right there. Also, if you'll notice, some other really cool things about a prism is that if you shine it on its end, you get some really cool like designs coming up on the very ends with the triangles and things like that. So you can always kind of fiddle around with those and see what different things you can do with the prisms. And that's all about refracting and reflecting light. Also, we have a device here called a spectrometer. And all it is it basically has one of those prisms in there, or a prism setup that's going to refract light. So you put your eye in through this side like a telescope, and you put the light in on this side. So we're actually going to set that up for you and see if we can simulate you actually looking through that light. I'm going to try to put it up to the camera lens here. Might take a second to adjust. I think we're getting it, almost there. Sorry, this is like really finicky. There we go. Okay, and so now we're pointing it at the light, and all it's doing is it's taking that white light and it's refracting it just like the prism did, and you see a really good rainbow there. Let me see if I can get adjusted one more time for you. It's really hard because it's a really tiny camera. There you go. So you see the prism and the frequencies all the way from red, orange, yellow, green, blue, indigo, and violet there. So very good setup for that. So once again, that is a spectrometer that does that. Over here at station number 2, your job was to take a glass of water and the flashlight, and you're going to try to angle it through the water to create that refracting light, because light is an electromagnetic wave, and it is a transverse wave, so it's going to move more slowly through liquids and solids than it does through gas. So as we point this light over here, you're going to start seeing some different rainbows and stuff, and it's kind of blown out on the phone. Let's see if I can get it. There we go. So it's kind of blown out on the phone, but you can see a rainbow showing up right behind the glass there. And sometimes you can get it to show up on the wall as well. Just depends on how you're angling that light. The next station that we had was, it's pretty much doing the same thing, but you're going to take the mirror, which has spaghetti noodles on it from our other station, because we can't clean up after ourselves, but that's fine. So you're going to take your light and you're going to angle it towards the mirror, and you're going to try to create a refracting of light onto the paper over there. Let's see if I can angle all 3 things at once. All right, so you see that rainbow on the left-hand side, that brightest section. It's kind of hard to see the diffraction of light right there into the different colors, but you definitely see the red and the indigo very clearly there. The next thing that we took care of is we were just recreating that diagram. In class we used spaghetti noodles and string and stuff like that, but overall you're just trying to get that overall effect where we see the white light going into the prism. It slows its speed down because it's entering a solid, and that's why you're going to see that white light split up into the different colors when it exits the prism. Over here, let's see if I can get something heavy enough to help me out here. So this was just kind of playing around with a rope to show the different qualities of a transverse wave. So as we're looking at this string, and I start to shake it back and forth, your first question is, what happens when you start shaking it faster? what did you increase? And so we see, as I start shaking it faster on this side, going from slow to fast, we have increased the frequency of the wave, which is the number of waves that passes in 1 second or in a given time period. Now the second thing that happens, or the second thing it wants you to do, is it's wanting you to go from a very fast wave to a slower wave. And it's asking what has been increased this time. And instead of increasing the frequency, we've actually decreased the frequency, which means that we have increased the wavelength. So that's going to be your distance between those crests. So the distance between those crests is much longer than the distance between those crests. The next thing that it wanted you to do was to pull your string tight again. And it wants you to go through a normal wave. And then it wants you to increase the energy of your wave. So we're still doing the same frequency, but we're increasing the amount of strength that we're putting into the wave. So even if we go like that, it's still the same frequency, but we are increasing the distance between the crest and a trough, which is going to be the amplitude, or the crest and the rest point, or the trough and the rest point. Also, and I can't really do this because I don't have my partner on the other side, it's just a cushion, but if I had my partner over there start shaking the rope at the same rate that I am in the opposite direction, there would actually be no energy moving through it. It would cancel out in the middle. It would just flatline. That's called destructive interference. However, if they did it at the same rate and in the same direction that I was going, we would actually increase the wave's amplitude as well, and that would be called constructive interference, which we talked about before. So those were the different stations that we went over. Actually, there's one more, I almost forgot about it. So this one over here was basically just taking an old CD, and you're going to hold it in the light, and you're going to see how that light refracts and bends on that disc as well. And so it has a place for you to draw a picture of that, and we see very clearly the difference between the red, orange, yellow, green, blue, indigo, and violet there. But anyways, that's what we did in Class A. Just wanted to make sure that y'all had that all set up and that y'all got to have somewhat of a hands-on experience with that. If y'all have any questions, please let me know.